We're recording.
All right, I'd like to welcome everybody to the March meeting of the HBRC Homebrew Robotics Club. Call this meeting to order. This month is special. It's our challenge month. It's our 22nd annual HBRC challenge month. 22 years ago, a group of us, we were meeting at the Cupertino Library at the time and lamenting some of the lack of building going on within the club. We knew that everybody had these robots they'd built and they sit on the shelves, been demoed one time and that sort of thing. So, and we had a contest at the time. We had a maze busting contest and a line following contest, but contests, they were winners and losers, and somebody was always unhappy. My tape wasn't that shiny, or I had a wider gate to go through the maze regardless. And then you had these structures that you had to set up and so forth. So we wanted something with no setup. We were meeting at the library at the time, and we thought, let's do tabletop soccer. We could have robots play soccer on the table. We'll put these nets underneath to catch the robots and yada yada. It's like, wait a minute. That's setup when you have to put a net around the table. And that's when it was born, the TableBot. TableBot is a robot to survive, live, and play on a table or pay the price. How do you get there? Bill Benson was known to comment that is non-trivial. And so how you get there is in phases. And that's where we came up with the phase 1, 2, and 3 that we did 2 months apart. So that phase 1 is to build a robot that goes from one end of the table to the other and back. Phase 2 is have it push a block off the edge of the table. And then phase 3 is have it move it into a shoebox mounted at the end of the table. And so, like the first year we had several robots come out and do that. We don't specify the size or color of the table, the block, the box, or anything. I've seen some awful big shoe boxes in my time, but regardless, the following year we expanded it and just called it the HBRC challenge, where we've got a floor bot challenge, an arm bot challenge. Now we've got an AI bot challenge, etc. My favorite is Run What You Brung, where you just bring in your homebrewed robot, whatever it is you're building, and show that off. So we normally do business news and club news and what I need help with, but I think I'm just going to go ahead and start this off with my TableBot. I've started the Homebrew Robotics Club of Tallahassee here, and we had our meeting at 7 p.m. Eastern time. And so here we are, 7 p.m. Pacific time. And so, yeah, here's Buggy 3 and TableBot Challenge phase 3. Can you hear the audio?
Phase 3.
Yes?
Can we hear the audio? There's an echo, and I think you're sharing the wrong screen.
You can't see the robot moving the can you see the robot moving the block into the shoebox?
Oh, we see
No.
a text page.
Okay, sorry, let me back out and try this again. Let me back out and try this again. One moment, please. All right. So, share screen. Share screen. Can you see it now?
Yes, we can.
Okay. Can you hear it?
3 attempting the TableBot challenge phase.
Yes.
3.
Are you not entertained?
Yay.
Yay.
You earned actual applause from the room here.
All right. Thank you. Thank you very much.
That's funny.
Thank you. Thank you very much.
Third time's a charm.
I'm not proud. You staying on the table, that's a phase one.
More like phase two. I thought.
I do get 5 minutes. And we're at the 2-minute mark. Yes.
Sweet. Oh, can't.
Thank you. Thank you very much.
Making sure it's in there. There he goes with his little victory dance.
All right. You can take the I'll take the spotlight off of me. Here we go. All right. Thank you very much. Let's keep the show rolling here. Do we have any other table bots out there? Dan, is there anybody with a table bot there in orbit?
Hey, Camp, I got a table bot.
You got a table bot.
So I'm going to share my screen.
Let me make sure screen sharing's on. Share screen is on.
Windows. This is confusing.
Okay, so we have 2 people in the room. Anybody else? Okay. You want to unmute, tell Camp, or should I text them?
Are you able to share your screen, Alan?
You just unmute it.
I'm trying.
Camp, we have 2 in the room here that we can do 2.
You-
All right, very
Yeah.
fine. I copy.
You guys, are you seeing a VLC?
We're seeing the pylon, yeah.
Yeah, VLC.
Okay. All right, this is, the sound should be muted, so I'm going to talk over it. It's only a 9-second clip. Oh, it looked terrible on my side. How'd it look for you guys?
Why don't you try it again to see if it's less pixelized? That's a phase 2.
That's a phase 2. Okay. Now let me stop sharing.
What's your robot's name?
Well, it doesn't have a formal name. This is the robot. It is a XRP, and this is one produced through the First Robotics program. This is the box, and it really is like a perfect entry level table bot.
Mhm.
It's 3D printed. It's a Pico, Raspberry Pico controller, and it has a sonar sensor, a line sensor, 2 odometry motors. They're gear motors. It's 3D printed, and it also has a servo and an arm on it. You know, have the world's worst web camera. But so actually I gave that TableBot challenge as an assignment, as a challenge to some of the students I mentored. And the interface to it is, they have a variety of interfaces, but they were using Visual Studio Python, no, Visual Studio Java to program it. And the only thing I had to do is make the table and put some black tape on the table, because the line sensor is a little bit too far back behind where the rollers are. So if it was the edge of the table, it would go off the table, and it does not survive going off the table
You can't
very
do a
well
phase.
because
They can't do a phase 4.
can't do a phase 4 because it's 3D printed, and landing on the floor will sort of break things. But actually, I think it's a fairly good entry, and they sell it to schools for like 200. They sell it to the public for around 400.
If you could put a link in the chat, that'd be great, Alan.
Sure.
Thank you very much. Alan Fetterman, ladies and gentlemen. Who's next? Who has a table bot? We're looking for table bots. Rohan, where are you at? Well, I see Roberto out there waving his hand. Roberto, you ready to go?
You're muted, Roberto. Unmute.
You're muted, dude.
Can you hear me now?
We hear you now.
Okay, fine. So Jim and I started this thing by buying your book and being inspired by it. So we stuck to the, the concept of the challenges as you designed it in your.
Did you use popsicle sticks?
Yes,
No.
we did. No. We are very sophisticated. You know, the title of, I have a presentation to show.
Okay. You want to share your
And,
screen?
Okay, yeah, I share my screen.
Okay. 5 minutes, Roberto. 5 minutes.
Okay,
No problem.
can you see it?
Not yet.
Are you sharing your screen?
I'm trying to share.
Then you
the
have to click share screen. There you go.
Okay, now let me go and do
Bingo.
okay, so unfortunately, okay, now here it is. So it says how to complicate CAMP's table bot. And this is it. This is the design. So we used the concept was to use belt and suspenders. So this thing has, as you can see, it's all 3D printed. It has an Arduino. It has the 4 IR proximity sensors. It has 2 motors, 2 of these yellow motors with encoders, and he has the sonar. It's a ping sonar, and also to add, just to show, we have also a LiDAR on it, as you can see on the next screen. First of all, let me go through the can you read the description?
Yes.
Is it hidden by some of these? Can you read it?
Yes.
Okay, so let me read it. This bot is jazzed up 3D printed version of CAMP's challenging table bot. It consists of a base plate, an Arduino Uno, a set of 4 AA size Lion batteries connected in series, and a small step-down converter that turns 15 volts from the batteries into 5 volts. A color-coded female headers rack powers the Arduino, the sensors, and continuous rotation servos. A main toggle switch turns the 5 volts, and the second one turns the Arduino. The sensor consists of a parallax ping sonar, a TF mini TOF optical ranging module, 4 perimetral IR proximity sensors, an optical quadrature encoder for each wheel, which is not implemented right now. The curve-shaped jaws serve as the block catcher with a micro switch confirming full. Okay, this is, you can see the jaws, you can see the ultrasound, and this is the LiDAR, and this is the micro switch that, in theory, should confirm the fact that the block is being captured. Now, you can see it from the top. You can see now here, phase 1. Okay? You happy with phase 1?
Let's see it again. Phase 1.
Okay. Now, let's go to phase 2. Oh, now, before we go to phase 2, we try to do a dance. So this is to show that it actually catches all the edges of the table. Okay, I can cut it short. You've seen it, right?
Yes.
Okay. Now let's go to phase 2. Phase 2.
Yeah.
Yeah, you want to see it again?
Yes.
You happy?
Phase 2. I'm very happy.
Okay, now Jim and I, Jim is a doctor, so he also has time, very little time to devote. This is the phase 3. As you can see, I added a top sonar like in your design, and it's not completed yet, but it will be finished by next time.
Okay.
So, any questions?
That's very impressive, Roberto.
Thank you. You know, that's what I do. I mean, I really complicate uselessly all my stuff. And so I like to do everything 3D printed, as you can see. Let me remove the sharing. How do I do that? Go back here.
Up at the top there.
Up in the top, step sharing, stop sharing. Okay. So can you see it? Oh, it's done. Let me see now. Let me remove the. Okay. Can you see? These are lithium-ion batteries, so it has a lot of range. It has the 3D printed ball as a caster wheel. And what is I think unique is that I created a rack. Okay, maybe it's not seeing very well. Can you see it? Right here. This rack here is made of 3. Okay, it's made of 3 rows of female connectors that one is ground, the other one is 5 volts, and then there are 2 that allow to pass on the signal from the device to the Arduino. So that doing that, it keep it kind of organized. It has a very tiny voltage converter that it's very useful. I use it in most of my robots. And then what is something that you cannot see, unfortunately, is that, can you see inside the wheel here? Okay, I 3D printed one of these optical wheels with, little slots. And it actually gives me an encoding signal with which I could actually do eventually a little better slam. And with the LiDAR, eventually we'll be able to do a little bit of a point cloud, and maybe do eventually put in ROS, although I have a version, this one has an Arduino, ROS doesn't run on an Arduino, but I have another version with a Pi, and Jim and I are trying to implement ROS2 and NAV2 and do a little bit of autonomous navigation and do, you know, the gazebo and all the stuff that comes with ROS2.
Roberto,
Hey,
this is
Roberto.
one of my earlier table bots. Talk about complicating things. It
Yeah.
actually had a grabber that would grab the block and move it in, and it had a tail back here that would drop to make sure it wasn't going to back up off the table.
Yeah, I mean, you know, I can tell, but you know, your stuff is done so many years ago that they value they're worth 10 times as much as what we do now. Nowadays, we have all these devices and all these programs that you didn't have. So I'm impressed.
Yeah, that was a stamp. All
Hey,
right.
Camp, we have a question from the room here.
Shoot.
Roberto, would you be willing to share your 3D printing files, maybe on the club alias?
My 3D, okay, I have a couple of 3D printers. I started out years ago with a Prusa Mark III's, and then I added an MMU for doing multiple filaments, and I got, you know, not very good results. The printer is very good, but the MMU is very complicated to.
The question was, would you share your files?
Oh yeah, sure, yeah, I can share my files.
Share them to the homebrew list, mailing
Yeah,
list.
right. That's right. You know, there are 5 different files. One is the plate. Then the other one are these, see, I made these things movable. They are slots. So I can actually stick them in and out because of the latency that the IR has. So I made them long enough so that it will actually catch the end of the edge of the table before, just about exactly before it falls off. As you can see from the dance, this thing here is really likes to live dangerously. It goes really, really close to the edge of the table.
Roberto Pensati. Thank you very much, Roberto.
Well, you know, this is not only me. Jim is.
Jim, I think you're next.
Oh, no, ours is the same presentation.
Oh, okay. You're gonna
Fine.
take Jim's.
We're partnered in this, so
All right,
Yeah.
Roberto and James. Very nice. That's awesome. That was really awesome.
Thank you.
Who else has a table bot?
Mark Johnson on this room has a table bot.
Mark Johnson, come on down.
I have a table bot, but I have a very flaky cell phone that suddenly is down to 20%. So that part will be a very short.
Makes
Anyway.
it exciting.
This is sort of not me at all, but it's for setting the tone, you know.
Can you guys hear on the Zoom? Can you hear Mark?
Yes.
So we have. Oh, where?
Can you-
Oh, yeah.
Can you highlight it? Pin him, whatever.
Is that not the one?
That is Dark Sky at Night. That is not Mark.
What's the camera? What's the camera's? What
Ralph,
Ralph Hips?
yeah.
How about
There you go.
that? Okay.
Hey, all right. We have a tally light, so I know which camera is on. Hang on a second, I wish. Okay, right. Anyway, this is Bender, as of course you all know. Bender is simply an object that's tall enough to trigger the sensors. So that way you can see this. And what this is Bender doesn't want to stand up that way. Okay. Nah. There you go. Sorry, it has to be backwards because I guess his feet are tilted. There are 5 sensors on the front, 2 facing down, and then 3 across the front pointing forward. So these 3 lines which are really hard to see, I bet. Oh, you can see them, yay, okay. So if I take this and move it off to one side, then you see most of him is on your right. And then if I go to the other side, most of him is on the other side. I think I might have to use my hand for this. For some reason, we lost that one. So there it is. Okay. So anyway, that's what he had used for an earlier demo, which is not part of the TableBot challenge. I'm going to now turn on this cell phone and hope that there's enough suds to do something. It has a Bluetooth GATT server on an ESP32 chip. Pay no attention to the tone. And therefore, you can talk into the bot's Bluetooth server with your phone Bluetooth, and then a custom app that's pretty straightforward. It's just, go right, go left, go forward, etc. And so that's what I'm going to hope to show you next. So we can turn this around. Okay, let's see. I would have just left it on, but unfortunately, like I say, the battery's playing a trick on me here. Okay, so I have a little app where I connect to ESPBot, because this is EspressoBot. And so the app is fairly simple. It shows you some status and some so forth and stuff like that. I'm afraid to disconnect the charger because I might lose everything. So we can say like forward or go right. Oh, that's actually rotate right. And now when you can see those things going back and forth and so forth. Let's see, reverse. Yeah, okay. Let's see how far you can go. So we're going to rotate this way. Has a little battery indicator. Oh, of course, we can't see the display anymore. All right. And then we're going to try, it's just rotating. It's not meant to stop on anything right now. So now what we're going to do is we're going to put it into a mode where it tries to rotate and find the object. So let's see. I think the easiest way to make that happen is to try not to use these controls, but yeah. So we're going to do another interesting trick that you guys can try also. And that is, if I hold the bot in one orientation and then turn it on, then you can use the accelerometer to say, oh, I'm in seek mode or whatever. Oh, it saw that guy. That's what happened. That's why it went that way. I forget which way it rotates, but anyway, you get the idea. You can put some cute little use to your accelerometers. So now it's rotating slowly and trying to find something in front of it, okay? Now, what it does is normally in the demo thing, it finds the thing, it rotates around, it goes the other way and tries to hit the edge of the table. I don't trust this table because it has this taper on it. So I'm going to be over here. So there, it's staying on the table. That's
Careful, it doesn't think your hand is table space.
is working really well.
Yeah, now you're going to jinx it.
Wow, I thought it wouldn't work because of the bevel.
You're stress testing it by saying that.
Wouldn't be there for the heck of it.
It's going to
Well,
think
see.
it's going to think
What
your
about-
hand is table space.
So anyway, rather than take up any more time, that's EspressoBot. And you can see it at mark-world.com. My other funner name for site broke. So mark-world.com. Any questions?
You use an ESP32 and you use what, Python to program it?
Okay, one more time, repeat.
what language did you use to program your ESP32?
Okay, is this one, this one is on Eclipse, and it's C language Eclipse for ESP32.
So
I
you're using,
also like more recently, I really like, I'm gonna put a plug in for Visual Studio Code because it's amazing. It's a really good thing. Yeah, and there's a second from the audience. But anyway,
So-
sometimes you do that as well with an Arduino. I'm sorry, go ahead.
are you using Arduino IDE to program it?
I do it, so I've got a zillion gizmos. If they're simple and I don't need it to be complicated, and I don't need free RTOS, this has free RTOS, by the way. And so if I don't need any of those kinds of things, then I'll often use Arduino interface. Now you can get an Arduino plugin for Visual Studio Code that also works very well. So that's a nice compromise. You got a better interface, you know, but it still does Arduino.
Thank you very much. Mark Johnston, ladies and gentlemen.
One more question.
Yeah.
One more question. How did you do the app on the Android? On the phone? That was did you have to write an app?
Yes, let's see.
And then Bluetooth, how hard is it Android Studio or did you have some other way? And did you have to write Java?
Okay, so let me cut to the quick. I would highly recommend, well, of course, now even this is 2 years old, but Unity. Look into Unity for doing Android apps. It's a pretty good system. However, this was made before Unity. It was made with an Eclipse conglomeration of stuff to allow me to. But that's a pain. So Unity, that's the one word to think about for Android app. And in these days, I'm sure there's 3 or 4 more that are even easier, but yeah.
Mark Johnston and the Espresso Bot.
Espresso Bot. That's under the run what you run. Because another bot which can't want to be great, which is called FigurBot, was typically my HBRC table bot challenge. Oh, and also another one called Robot. But I've been rejuvenating the box, getting back running again, and sadly, as I mentioned earlier, well, everybody, why I've been here, but it wasn't working quite right. I figured, oh, I will just reload the firmware because the server wasn't working and go off. That's all. But that, you know, I know I should.
We're not getting Mark's audio.
I'm definitely interested in this young man's problem. Thank you.
Dan, do we have another presenter there, Ed, in orbit?
We have another presenter? Ready to go? You need time to set up or?
It's not a keyboard, it's not a table board.
No, that's fine.
Yeah, but it's not a table.
Do we need to move the tables out of the way or you good?
Don't go to board. That's fine, it's a table board.
It's a table bot now.
It's a table board now. So I'm trying to do a 3D printed 3 feet tall humanoid robot. And this is the leg mechanism, right? And the leg is the tricky part, so we're focusing on the legs right now. And also, this is a side project. It's not my day job, by the way. Just want to make that clear. So the idea is, you know, stick with small robot, it's safe, and make it open source. So the kids can, you know, download the design. You would have a template to start with, but the idea is that they can modify the design and you can build, you know, hundreds of different humanoid designs, right? Then what I'm hoping is we can organize a competition between schools. So you can use this, build your own customized robot, compete with other schools, win the competition. Yeah, that's pretty much it.
You can't tell back here, but that belt driven.
Yeah. And it's all belt drive, it's low cost servo motors. It's actually gimbal motors, not the drone motors, but very similar. And then you have a 1:10 belt drive. I have another leg here. If you want to have a look, yeah. So that's a motor here, and then there's a belt, and same.
It's gonna be a lot easier to walk with 3 legs.
With 3 legs of it.
You have an extra legs.
Yeah, there's supposed to be a hand.
So can
Yeah.
you tell us why you decided to go with belt?
It's first of all, you don't need it doesn't have to be precise, right? Gears, you need a precise alignment. A belt will take a lot of slack, and also, with 3D printers, all have belts, so you can source belts really cheap, timing belts.
And can you tell us about the feet? Because it doesn't look like a traditional foot.
Yes, yeah, that's a trick, right? What we've done is it's a 3-dog leg. So to balance and move, you only need that, because 3 and 3 is 6-dog. So 6-dog is all you need to balance. So it's not going to be able to stay still. It always have to move, take micro steps, right? But the intended use is school and competition, so it's fine.
So it's balancing feedback loop.
Yeah, it's balancing. It's continuously balancing. It can never be static.
Okay. And a lot of people like that.
Yeah, there's a couple of people doing it.
It's especially.
What is the project name? What is the name of this project or product or?
There's no name at the moment. We're calling it Robotown, Yeah, we don't have a name yet.
Can you put a link in our homebrew mailing list so that we can, have access to the information on it? Dan, your audio went away.
Actually, all 3. There's 3. 1, 2, and 3. They're all actually. All motors are all. Yeah, on the hip. So that's a trick part. You want to keep the leg really light, and the lighter your leg, the better the balance of performance. The time constant required to move that leg is pretty low.
Are you using for like a high level control for this, right? To keep doing like an inverted pendulum for the kind of low, low degree for you kind of high level control analysis before you do the kind of low level individual servo controls? What's the how many levels of that control?
Yeah, there's going to be 2 level controllers. So there is these motors. I should have bought some motors. They're pretty cool. They have controllers built in, and you talk to them over CAN, and you can command torque or velocity or position. Pretty cool stuff. They're not that.
Or something else.
What?
Is that Dynamixel or something?
It's not Dynamixel. It's called My Actuator. It's a company in China doing that. It's similar to the MIT Mini Cheetah project. It's all spun off from that project.
All right.
What's your name?
My name is Anish. So I sort of said that. Anish.
Please spell.
ANISH.
Amish.
Any more
Very
questions?
nice. Thank you, Amish. I'm gonna call
There's
your
a question.
robot. I'm gonna call your robot roller legs.
Question in the room?
Yeah, so, and for the future robot, are you going to have a rotating waist and changing the distribution or weight distribution, rotating shoulders? So you're always rotating with the wheel.
No rotating waist. You'll be rotating with one leg up. What I want to do is 2 arms, right? So total it would be about 3 feet tall. And it would use the arms for dynamic balancing.
And so arms will move and change the weight distribution. Shoulders won't move, waist won't.
No. So that's why the leg is so light, right? If you have a disturbance, you move your leg. And because it's so light, it can move very fast. Right. And there is actually, I saw there was a Chinese company which has released a video of something similar like this with the box on the top, and it balances really well. And we have, we had inverted pendulum setups that balances fine. It's doable. The trick is to have very good torque sensing. So the idea is we are using the large diameter gimbal motor and a very small gear ratio, just 1:10. So you can sense the torque pretty well.
Chuck, do you have a question?
Yeah, well, I mean, I wanted to dig deep into the mechanics. So
We
what
don't
are you
have
doing
time
for
for
your
that.
what are you doing for your reductions? Are you doing anything outside? It looks like you got some timing belt reductions there, or is it like a cycloidal reduction or harmonic or anything else in there?
No, there's nothing else in there. It's what you see, it's just a direct drive gimbal motor. So gimbal motors are what you use on the camera gimbal systems. There are like high torque, low clogging motors, and then we just have a one-stage reduction, a belt drive, standard belt drive. I have a metal pinion used for 3D printers on the motor side, and on the joint side, it's just a large diameter disc 3D printed. Everything, almost everything here is 3D printed.
What's the name of that motor again?
My actuator, they've made it really simple.
Okay, thanks.
Thanks, Amish. And roller feet.
What'd you say, Cam?
I said, thank you very much, Amish. And roller feet.
Okay.
That was very interesting. Is there another presenter at In Orbit?
There is. Take a turn. Okay.
I'm Rohan. I've been in the club for a very long time, but I took a 4-year on and off break to go to college or something. Someone said I needed an education. I think it just got in the way. But yeah, so I'm here. I built this robot about a year ago for a microcontrollers class. The requirement was we had to have a microcontroller take in sensor input and have some observable effect somewhere. So might as well make that a robot. So let's go to the demo first, and then I'll say what it's supposed to do.
Yeah, I don't see it. Yeah.
So it's doing the phase 1 table bot, and
Yeah, hang on 1 second. Whoever's controlling Camp, Thomas, can you unpin Camp so we can see the robot? Because right now we're just seeing Camp chuckling.
Go. You weren't on video, so it's okay.
Well,
Camp, can you hear me, Camp? Camp, can you hear me okay?
Camp or Thomas, can you hear
I'm
us?
working on it, guys. I'm working on it.
You're pointing the camera at the screen now, though.
Yeah, I'm just highlighting the fact that we're not highlighted.
while
Yeah,
we
but
wait for
I pinned him myself, though.
yeah, so while we wait for camera, the kind of different
There we
thing I did
go.
this time.
I got it for you.
Is as you can see, it slows down before it reaches the edge. The way it does that is that it's using this time of flight sensor. This is that. Let's see if it works this time. There we go. It's using that time of flight sensor. So that's a part from ST. It costs about like $2 or something, and it gives you an 8 pixel by 8 pixel grid up to 2 meters. So it's a little depth camera, and using that, I can make a point cloud, figure out where the table falls off in the point cloud, and slow down before I hit the edge. I still use the downward firing sensors just for backup, but about like half the time it works just on the time of flight camera I'm working on, trying to sort out the rest of the bugs. So Yeah, that's basically it. Yeah, what's up?
Is that the Romy chassis
Yeah.
in Palolo?
Yeah, so this is the Palolo Romy chassis with a custom board on it that has a STM H7, so one of the big boy microcontrollers. I did that just so that there would be plenty of processing power. The Raspberry Pi is there for ballast because it's a little front heavy and it tends to fall off the table.
It's a good use for one,
Yeah.
actually, yeah.
It was also actually used because I used it as a wireless USB, so I can just connect my JTAG up and then USB over IP so that I don't have to keep plugging and unplugging the programmer from the robot, every time I want to change some parameter in the firmware. Okay. Any other questions?
You've come a long way since Canon Go Boom.
All right. Oh, thank you.
Thank you very much, Rohan.
Okay.
Yes.
Yes.
The robot with members of group. Yep. There's one. Are you ready to go right now? Yes. Awesome.
That was fun.
William. William.
Oh, hey, William.
So see that. So this on online. So this is not table. Is it okay if I put it on the floor because I might fall off?
Oh.
Whatever makes you happy. Yeah.
It's a floor bot. It's a small floor bot.
The biggest thing about this, there's a couple of things. It is controlled over internet. So I'm having a hotspot on the robot that is connected to my laptop. And it is also streaming video, which is visible on the laptop again. So you can look at you. So,
Yeah.
So that is live footage of the robot. And you can pilot it.
Are you driving that, William?
Yeah, so I can drive this guy around.
Audio is kind of muffled.
Cool.
Yeah, one of the biggest things I have when I was making this is being super cheap. So
You're controlling that through a web server, right?
I'm controlling it through a WebSocket. The robot has an ESP32 chip that is acting as a server. And that's what I'm using to pilot it. And I am also working partially on having general internet control. So there's like two methods I have of controlling it. The first one is directly from access point to laptop. And the other one is access point to, well, actually, it connects to a server I have somewhere in the cloud. And then my laptop connects and it does a relay system, so you can control it from anywhere. And I have my other robot, but it's a little laggier, so I'm not gonna try to do that today.
If you want to keep that from tilting over, you understand you can put a ring over the.
Well, I'm gonna put something like artificial like slowdown in there, so that way it can't change direction so quickly. That was my current plan on fixing that.
Can you see the sound?
The sound?
Yeah, go outside, duct tape stone to it. Spray.
That is true.
Duct tape.
Yeah, so I've been trying to keep this guy at really low cost, $130 for the whole robot. And I want to get the whole swarm run that I can just kind of bump the car with, and yeah, then I can have
Well, maybe the image recognition.
image, it is currently something like I think it's like 400 by 300. Is that it? Yeah, that's pretty. Yeah, so it's a pretty small resolution. You could go higher, but I'm trying to reduce latency more than anything. So I decided to go with a higher resolution then. And yeah, that's basically about.
William Sokol, thank you very much. Did you say you had a second robot to show? William? Did you say you had a second robot to show?
Well, I have a couple of the same one, same shoulder. Yeah. I just got a couple of. Got a couple of. I haven't. But yeah, that's basically it. So, yeah. You make them Corey. You know, it's gonna be tricky to do that, but yeah, absolutely, I'm trying to. Okay. Thank you. We have any more robots to show? We're out of robots, Cam.
All right, sounds good. Let's keep this show rolling. Online folks, Dee Dee, I think you've got an arm bot, don't you?
Yes, I do.
There you are.
Okay. So yeah, I'm pretty excited because in a week and a half, the San Francisco Symphony is doing a music with robots program. So this robot was selected to be one of the robots there at the San Francisco Symphony. So that's pretty exciting.
That is awesome.
So I made this robot 5 years ago, and I've been, taking it around to different events. So since it's going to the San Francisco Symphony, so I said, well, we need to do some work on it, especially since it wasn't clear whether or not I would be running it for both nights. So maybe someone else. And normally I'm used to just starting it up myself and logging in. So I took that as a challenge for being an engineer.
Tell us how it works, Dee Dee.
Yeah, so what I did was took out the base because so it rotates round and round. So there's a base with bearings on it and just a standard servo. So I added support to the base because it was flexing apart and sanded down the bottom layer. And then I added wax and bearing loop so it can rotate more freely. And then there's some sonars here, a sonar array right here. So the first time before I hadn't really gotten it working. So I looked through to see whether it was the wiring or electronics or the code. And I realized my Arduino code didn't reflect what pins it was connected to on the PCB. So I updated that. And then also these array of LEDs above it. So I tested the code for that. And then so there's an Arduino controlling all the motors. There's 2 micro servos here doing the eye movement and a mega servo doing the arm. And then those are all connected to a Raspberry Pi. There's a Raspberry Pi cam over here. So it has Python code. And if it sees your face, which I guess it doesn't see it now, but oh, there it is. It saw my face. It will display my face. Welcome. It's just using since it's 5 years ago, it's using a simple CV algorithm for face detection. So yeah, that's pretty exciting.
What's your robot? What's your robot's name, Dee Dee?
Welcome bot. So it's a full-size welcome bot. I have some smaller ones. Let me see. Some mini welcome bots that don't have all that modern those modifications, but it's nice because you can just plug it in and it waves your hand. So I added an extra button, and so I plan to have it auto start the Python when I plug it in, and then just a button so it will turn off, shut down, do the shutdown routine in the Raspberry Pi instead of having to take out the keyboard to do it.
All right. Thank you very much, Dee Dee. And that's the welcome bot and the ARMBot challenge. ARMBot challenge phase 1. Build a robotic arm that moves or waves. So there you got it. Thank you. Moving right along. Jimmy from Australia, you got something?
Yeah, hey, I have, can you hear me?
We can hear you.
You know, I make the AI challenge.
Okay, the AI challenge.
Yeah.
What phase?
Oh, this is just phase 1.
The AI challenge, phase 1 is have the robot verbally chat. Phase 2 is ask the robot to identify an object in the room visually. And phase 3 is have the robot manipulate the object. So you're going to have it, you're going to make your robot verbally chat.
Yeah, I'm hoping he'll talk to you now. I just turned him on. Having a bit, I've been working with his microphone and it doesn't work quite as well. But we'll give it a go. I'm hoping you'll be able to hear it. Hey, Patch? Yeah. Please tell me what the Brew Robotics plug is. Do you know whereabouts the club is? I'm sorry.
So is this is this robot, is this a physical robot or are we talking
he
to a
is,
computer
yeah.
screen?
I'm sure, I'm sorry, I'm sure I'm on this camera here. And I'll show you, yeah. I moved my camera. There he is there. This is the microphone I'm talking to through. And this is his loudspeaker. I've just disconnected it from the private chassis.
Yeah. Put your microphone right up to that speaker next time.
Yeah, I've got it as close. Yeah, he's a bit.
We're hearing it. It's kind of cutting in and out like a bad cell phone connection when he talks.
Oh, is it? Yeah.
Try it again.
Yes.
Because it's it might be the noise removal system of the Zoom.
Yeah. I could try him again. I say, hey, Pat. Yeah. Please tell me what a giraffe is.
A giraffe is a long-necked animal, large animal native to Africa. It is known for being the tallest land animal with distinctive coat patterns. It mostly feeds on leaves and vegetation found in tall trees.
Yeah, so did you hear that?
That's better.
His response, yeah. So what the vision is to have a robot that moves around the house. I've got him here with he's a four-wheel robot. It's quite
It sounds like someone was discussing a vision or idea about incorporating a robot with a hand. The specific nature of this concept might be an AI-controlled device in a form of a hand.
Yeah, I just turned him on. The vision is to have this robot drive around the house, and I intend to put a camera on him. I had a previous robot that I had visual recognition on, facial recognition, but it wasn't very good because all he could do was recognize the because he couldn't see face because he was down on the floor. So
That's
I'm gonna-
awesome. That's awesome, Jimmy. Now,
Yeah, so that's-
what large language model are you using on that?
That's GPT-4. I've also been using Claude as well, but I don't like Claude as much. It seems to give. I'm not sure. That's just preference. I'm not sure why. Also, I find Claude a bit more expensive. I've been using GPT-4. I gave it $10 a while ago now. I have half budged by $10, but using Claude, you get $5 free. And I used up $1.50 just in my back. So I'll choose that.
All right. All right, Jimmy, thank you very much.
Okay, well, that's that.
That's Jimmy McKerney in Australia with his Chat GPT-4 robot. Hey, Jimmy, we do this in a couple of months again. We'll do this in June again. So looking forward to your progress and looking forward to some of your posts on the mailing list.
Yeah, sure. I'll do that. I'll put his camera on you.
Very good. What else? Who else this evening has a robot to demo?
Well,
Jim Nunzio. All right, Big Orange.
I just have a
Truckster.
Work in progress for
Truckosaurus. All right.
You want me to go or give me a minute? Give me a minute or is anyone else going next or you want me?
I see Thomas raising his hand. Thomas, are you on?
Yeah, I'm on.
All right, let's go.
I gotta take the phone in the other room and give you a live demo. If the live demo doesn't work, I have a video.
Hey, been here before.
Okay, make sure you pin this one, not the other one.
I'm trying. Is the Betty 9?
Yeah, let me see. It's blurring the background. Let me see if I can unblur the background.
Turn off your background.
Yeah, I'm working on it.
Blue there.
Oops, that didn't work. What happens if I go real close? Will it bring her in? There we go. Look at that. All right, just got to start the motor. Just give me a second here.
See if you can turn off that background.
Yeah, if I could, I would. It's on the phone. I'm not sure how to do it on the phone.
If you look at the image, there should be an option to turn off background.
I'm looking at it.
In the ellipses.
There's no ellipse here.
You may have to tap the screen and then some buttons show up.
Oh, there we go. Background and effects. Found it. There we go.
Betty 9, ladies and gentlemen.
Yeah, let me push the go button. Hold on.
Stand back.
Yeah, stand back. Gee, that works really well. Let's try that again.
We're not getting any audio.
Yeah, I know. The amplifier shut itself off.
Hate it when that happens.
Save the battery, I suppose.
Going to sing the Ghostbusters theme song. Hit it, Maestro.
Let's have her say that one more time.
Hello, my name is Betty 9. I am very glad to be here at the Home Brew Robotics Club. I heard that this is a good place for robots to hang out. Hi, I'm Little Robot of Humor. Anyway, since the new Ghostbusters movie is out, I am going to sing the Ghostbusters theme song. Hit it, Maestro.
She's going to sing the Ghostbusters theme song.
This is awesome. This is awesome, Thomas. We're not hearing the song though. Hey, Thomas, the audio's not coming through here. I ain't afraid of no ghosts. Hey. I think the audio is coming out of your computer or something. All right, Thomas. That's it. The audio's not coming through. Thomas. The audio's not coming through, Thomas. All right. That's it. Thank you, Thomas.
Camp, are we on to the next robot?
We are moving on to the next robot. Who else has a show and tell this evening? Phil?
Oh, no, it's back.
It's back.
Oh, no, I think it's possessed.
Betty Nine, ladies and gentlemen. And new Ghostbusters theme. All right. I think we're about to wind it up here. Does anybody else have a show and tell?
Hi, Camp, you want me to? I'll show you mine. It's not a
You're back. Go
it's
ahead.
not a moving. It's not actually
Tell us about Truckosaurus, your Robo Magellan robot.
So I've been working on a Robo Magellan robot very feverishly because I kind of work on Orange so much that I didn't spend enough time. So here is Truckosaurus in work in progress, and I'll show you. I'll just do a static review of him for you, of his features. So Truckosaurus is a Traxxas RC crawler truck, 4-wheel drive with one motor, driving all
Can we go
4
full screen?
wheels.
Can you go full screen?
Can you see my yeah, you should pin my camera, I guess. You guys
Thomas, can you pin it?
Oh, okay.
Okay, there you go. So that's better for me too. But just the last couple of days, I have mounted the camera and the LiDAR assembly here. This is an Oak D light stereo camera, and it's on a pan tilt two degrees of freedom. Because I'm so used to doing this with orange, I figured I had this hand tilt, so I wanted to use it. And I'm so used, yeah, with orange, orange might be facing slightly askew to the object, but with this extra degrees of freedom, you can find an object independent of the direction of the vehicle. So this is my SlamTech. It's a mapper device. It's a full PC board proprietary system with a time of flight LiDAR here actually. And it has Ethernet output, and it will publish it publishes in raw. I have a raw development environment for it, so it will, when you run it, it will publish the ODOM, and it can localize through, and it can map with this full system in here. It's a whole computer in there, which I don't really care about. I just have an API. So that's the outside so far. Now we'll see the inside. Hold on a sec.
We lost the video.
Just hold on a sec. So now I've taken the cover off.
It's out of focus.
Yeah, what's the trick on these things? Why is it not focused? There's no focus on it.
I think it might have that blurring background.
Oh, there it
Oh,
goes.
now.
No, it's that these are like they're just they focus based on the image. So all these orange parts are 3D printed. So what we have here is a Teensy 4.1, which is going to be it's not wired up at the moment. So essentially this is the underside of the RC car, and I had to find, I wanted to pack everything there. Here's the single motor that drives all four wheels. So
This is a Traxxas monster truck, right?
yeah, it's a Traxxas crawler. So I had to find places to mount all these electronics. So here's the Raspberry Pi 4B, and this has all been screwed down. This came with the device. This is the ESC, a controller for the motors. Over here, you have a few different things. This is the GPS module, the Adafruit Ultimate GPS. The antenna is coming out here. I'm going to have a big antenna connected. This is the, like I said, the Teensy 4.1, which will control the PWM. I've already got software running, initial software I won't demonstrate that right now, but I had to take it down to get the hardware set up. And here is an IMU 9250, which goes into the Teensy, along with the not the GPS goes into the Raspberry Pi. But this is the layout of the whole car. And in the back is I made a tray. So all these orange parts I either had to design or download from the internet and modify if I needed to hold these different boards. And then this one is my battery pack for the electronics. And I made a little cargo tray, and that's wedged in, I found, onto these supports.
All right, very good.
So
that's Jim D'Annunzio in the Truckosaurus, and that's your Robo Magellan robot 2024.
Yeah,
Camp, can I do
I'll
something?
give an update later.
Camp,
Thank you.
can you hear me, Camp?
Yes.
I have a second robot to show.
Okay, real quick, we're running out of time. Give you 5 minutes.
Okay,
Go.
very quickly, because I have a question. This is a little more complex robot that is based on a Jetson Nano, and essentially is a JetBot. And the JetBot, however, does not have the ability to read encoders. This bot here has two DC motors with encoders, and in order to be able to do all using the encoders to do, first of all, to tune the two wheels in such a way that they work straight, and then to be able to do object recognition through the Jetson Nano, I needed to use a different motor controller, which I use a RoboClaw. I don't know if you guys are familiar with a RoboClaw. RoboClaw is a very sophisticated motor controller, which is able to get the information from the encoders, process it, and then sends it to the motors. The problem that I have with this, well, you can see that it has a voltmeter here that shows the input voltage, which is 12 volts, and it sends it out to 5 volts and 9 volts for the motors. The problem is that the Jetson Nano issues the information in an I2C serial protocol.
All right, Jim. I meant to say, Roberto, we got to move along.
Okay, so the RoboClaw cannot read I2C. It only reads UART. It has the TXRX pins. So I need to convert the signal, the serial signal from the JetBot, the I2C, into a UART. And I don't know how to do that.
Why don't you
Can anyone-
post that, put that together and post it in an email to the HBRC mailing list, okay?
Well, that's the who needs help. That's
Well,
the-
but we need to move on because we're wrapping it up and we still have a few more demos to do, okay? Yeah, hang on a second. Thomas?
Yeah, sorry about that. I forgot to turn off the volume.
That's okay. A couple of us, Alan, Phil, and Thomas have been working on the mock turtle bot, and I've got let's see, I've got it on video here. Here it comes. So here's and I won't go through the whole thing. This is the Smarty 2, the one in the middle there, is doing Floorbot Challenge.
Are you showing the wrong screen?
We've seen your documents. Docs.
Okay, sorry. There you go. How about that?
That's better.
That's it. Looks three-dimensional. Three-dimensional sticks coming on it.
Yeah, those are the transforms, the Ross transforms is the turtle bot. And it's got the camera on, it's a Logitech camera. But as you can see, I'm navigating from one end of the apartment to the other. And back again. It does it like 3 times. So that's a Floorbot Challenge Phase 1. That's a triple-decker Floorbot Challenge Phase 1. What else? Do we have any other robots for show and tell this evening? Going once, going twice.
Hey, Camp, how much of that My Robot did you actually see?
We saw a lot of your robot. We did not hear the music though.
I got a 15-second clip pre-recorded. Do you want to hear it?
Is it Betty 9?
It is.
What do you folks say?
About 15 seconds.
I would like to hear.
Dee Dee wants to hear it. Put it on. Hurry.
He wants to hear. We ought to do it. Am I sharing the right screen? No, I'm sharing the wrong screen. Let's try that again. I hate when that happens. There, that's the right screen. Okay, how about some noise here?
All right, that's it, Thomas.
And that's it. That's all she wrote. Are you not entertained? Are you not amused?
I am amused and entertained. Question is everybody else? All right. Before we go, are there any more robots out there to be demoed? I'd like to thank everybody for coming out and bringing your robots and showing them. I know a lot of people go through a lot of time, energy, and effort, and stuff just didn't work out. So again, I want to thank everybody for the time, energy, and effort they put into it. I hope you were entertained. And with that, I motion that this meeting be closed. Do I have a second?
Second.
All in favor, say aye. Aye.
Aye.
Those opposed, nay. Ayes have it. Meeting adjourned. Thomas,
Thanks, Cam.
recording. Now